So today is we're going to be talking about FaaS and the Curious, AWS Lambda threat modeling. Brief introduction, go over FaaS, some of the AWS services that are relevant to topic of discussion today, different attack vectors for AWS Lambda, and then some of the mitigating controls that you can implement. So, as Laurel just mentioned, my name is Brian McInich. My handle is Aphex. You can reach me on Twitter at Brian McInich. I'm also the founder and executive director at Pervade Cybersecurity, also on Twitter at Pervade LLC. As Laurel just also mentioned, background 20 plus years, pen testing, security architecture, variety of things, cross-disciplinary. And been focusing most recently on cloud containerization and AI. No blockchain, no blockchain. So before we get started, I want to give a couple quick shout outs to sources of inspiration for this talk. There's a gentleman by the name of Rich Jones. He's at, I'm going to think that's gun.10, I believe, or no, I'm sorry, gun.io. He did a presentation called Gone in 60 Milliseconds a few years back, and he's been building on that research. It's really good research, a lot of good inspiration for this. Also, Andrew Krug, I think presented at, if I'm not mistaken, was Black Hat 17, Black Hat USA 17, and he presented on hacking serverless runtimes. And then also just a shout out to the DFW hacker community. North Texas Cybersecurity Group, Dallas Hackers, DC 214, DFW, and OWASP Dallas. We've got a great community up there. If you've never visited us in Dallas, contact me afterwards. I'll put you in touch with some people. We've got a really warm, welcoming community. A lot of talent up there. So more to the point, what is FaaS? So just by a quick show of hands, I know this is OWASP, so a lot of you are going to be familiar with at least some of this. Cloud technologies, just by show of hands. Okay, and then container technologies, Docker, Kubernetes kind of thing. And then Lambda or function as a service in general. How many are you familiar with that? Okay, great. So function as a service, AKA serverless, it's not really serverless. It's running, it's bootstrapping code, running a container that does that. It's very minimal infrastructure, application deployment, event-driven execution. So think of a if this, then that. Something happens, triggers your code, it runs, does what it needs to, and then the underlying container goes down. So some of the benefits, again, minimal cloud infrastructure, minimal operational overhead, really facilitates a lot of efficiency in a DevSecOps, DevOps, CI/CD pipeline environment. Some of the growth estimates for this that I found, because we keep moving in this direction of faster and faster deployment times. Estimated valuation of $7.75 billion in USD by 2021, and forecasted to grow around 33%. So pretty fast growth. We've got cloud, and then we've got containers, now we've got this FaaS. So some of the benefits of it. So we started off with rack-mounted servers. Still have some of those. A lot of people still use them, but the direction we've moved is how do we get this deployment time down to as minimal as possible in terms of time and as minimal as possible in terms of cost. So, rack-mounted took days. It was high cost. It took a lot of people. We moved over to virtualization. We're cramming more resources out of that hardware. So we can run multiple virtual machines on a single hardware platform. And then the powers that be said, well, that's not enough. Let's get a little bit more out of that even. So now we've got microservice architecture where we're running containers that are providing a single service rather than a monolithic. And the evolution now is toward FaaS, with Lambda specifically in this talk, where we're bootstrapping code on the fly as needed. And then obviously that's a lot faster and much more cheaper. So AWS services. When I originally started doing this and kind of tinkering with Lambda, I was talking to a friend, and he mentioned that Lambda actually is not serverless. It's running on a container that runs your code, et cetera, et cetera. So I started scratching my head, and I was like, well, if it's running my code, maybe there's some possibilities for abuse. So reading through AWS's FAQ, this is what they had, but this is kind of what I kind of pulled out of that paragraph that runs your code on underlying compute with some back-end services. And it just seemed like it presented a lot of opportunity for research. And it did. It's really interesting what I've learned. So Lambda, again, I'm not going to read through all of them, but it's got a lot of really cool features. I think probably the biggest one from a security standpoint is that it's the statelessness of it. It's very ephemeral, the resources that you're executing and that it provides. And then it's got a read-only file system with one exception, and we'll get to that a little bit later. So this is my attempt at drawing up a kind of a Lambda architecture. We've got the events on the left side here that could be DynamoDB, simple notification services, API gateway, CloudFormation template, S3. There's a number of things that Lambda supports as a trigger. And from my understanding, maybe a little bit presumptuous of me, but I'm assuming with AWS's Elastic Container Service, otherwise ECS, it's probably what Lambda is leveraging, which runs in EC2 clusters, which execute a Lambda, which would be your code that runs on a Docker container. So, and all the code that I know of currently that you can run would be Python, Node.js, C# and Java. I think they're adding more pretty regularly. So again, from left to right, you've got an event that triggers a Lambda function that's invoked using the language of choice that you've written it in. So here's an example, kind of a sort of a hello world. We're receiving input in a JSON format. So we've got key 3, value 3, key 2, value 2, key 1, value 1. It's invoked into the Lambda function. You can parse those values out, do whatever you'd like with them. But for purposes of illustration, I'm just printing out the key. And then what you see over on the left is what's actually outputted. So again, this could be, we receive input, we write to an S3 bucket, we invoke another Lambda function. There's endless possibilities of what you can do with Lambda. By the way, if you have any questions, open dialogue throughout. If something comes up, you have a question, please feel free to ask. So within the context of this, also we want to look at identity and access management within AWS, because that's the foundation of their security architecture. You've got roles, policies, users, groups, etc. So this is just kind of telling you what you can use it for, how it enforces it. Again, some of the attributes, we've got a user. It's really no different than what many of us would consider a user. It's a person or service that you're able to log into AWS Web Console. You can use their API using your API keys. You can also use the command line interface with AWS CLI. It's authenticating with a name, password, access keys, but by default, users are created with no permissions, not even the ability to change their own password. So kudos to AWS. They've done a really good job with IAM on locking down an environment. You literally have to go in and explicitly grant permissions through policies and group settings. So group, again, no difference really from maybe like an Active Directory group or a Linux Unix group. It's just a collection of IAM users with common permissions. And again, just as most groups do, is administrative convenience for granting and revoking access. Roles in AWS are a little bit different. It's an identity that's assumed temporarily, but there's no associated credentials with a role. So you could have like an EC2 instance that needs access to several resources. You could create a role, attach a policy to it, and attach that role to an EC2 instance, or a Lambda function, or a number of other things. So it can retrieve credentials locally from an EC2 instance metadata or AWS simple token service. So there's several different ways to do it in AWS, very flexible. So the policies are kind of a double-edged sword, and we'll get to that just here in a sec too. It's a JSON formatted object. This explicitly defines permissions, again, because AWS has like a deny by default security policy for IAM. So they give you several different ways. They have AWS managed policies, predefined templates that you can use, or you can go in, define your own with like inline policies. They're very granular, but they do support entity wildcards, asterisks. So if you look at, let's just say, all the different S3 permissions, and there's tons of them. You got get object and put object, and there's so many. If you just want to give a resource or a user access to all of those different permissions, you can just put in an asterisk, which, as we know, wildcards can be dangerous if used inappropriately. So this is my little joke with IAM. So this is just a really simple sample policy to allow a user named Colonel Sanders access to a KFC S3 bucket. And you can kind of see how that could get a little confusing, especially, again, deny by default. We've got to go in and explicitly define who can access what. It's good from a security standpoint, but oftentimes when we're going through and maybe troubleshooting, or we need to get something set up and configured very quickly, most people are going to resort to the wildcard, get it working, and maybe we don't come back and revisit that. And that obviously presents a problem. So we get into the meat of it here. Again, this is kind of a threat modeling talk, so I want to throw up this disclaimer because it's important to note that all the attack vectors shown here assume that applicable permissions have been granted through IAM roles and policies. So I'm not circumventing IAM by any means. This just assumes that those permissions have been granted already. But because of the deny by default, they're very esoteric. It's very granular. It's not unusual for them to kind of grow very lax over time. Some of the culprits include like serverless web service frameworks, automation tools, third-party solutions. They want to get their solution integrated into your environment very quickly. They're just going to set up very, low barrier to entry, easy to implement policies. They don't want to spend their time trying to troubleshoot and make themselves look bad, so they give you something very simple to put in. And then just untrained or lazy, apathetic cloud admins. Again, I mean, I'll speak for myself. I'm guilty of this. I think we all are. We've probably gone and said, you know what, I'm just going to do this. It's a lot simpler this way. So the attack vectors are not necessarily any different from other attack vectors, but it's just a little bit different context because we're talking about cloud and how AWS enforces this. So we'll start off with some active reconnaissance. So I started tinkering around with Lambda and saying, what kind of code can I execute? What can I do? Where can I write? Where can I read? Look at like some credential hijacking that we could do, like maybe like a insider threat or a rogue employee, some sort of scenario like that. How can we gain persistent remote access through Lambda? And at the end here, we'll try to step through some reverse engineering. At the end, I'd like, if anyone in here is like a Python hacker or knows Python really well, I'd like to either talk to you during the presentation or afterwards, because I'm still working on some stuff and I have some ideas and I'd like to solicit some of your input. So curious minds want to know. This is just kind of the thought process when we're looking at Lambda. How can we abuse it? How can we attack it? How can we make it do things that it's not intended to do? So first and foremost, we want to find out where credentials are stored. So if we can find credentials, then we can start poking around and seeing what we can do with those credentials. How can we abuse them? What's the operating system that Lambda is running on? How's the network configured? Because Lambda's communicating with other resources, some internal to your own environment, some perhaps in a public internet space, some maybe in another another customer, another tenant's environment. What are the file system permissions? So again, can we read, write certain directories and files? Which processes are running? This is going to be a container that's running underneath Lambda, so containers have very minimal processes, but we want to find out what's running and how we might be able to abuse some of those. Most importantly, from how we can do things is how our code is bootstrapped within Lambda. How is Lambda taking our code after it's been invoked and doing what it does with it? And then with that, what data can we control? What sort of environment variables? What sort of bootstrap variables? What sort of information can we control, and how can we maybe change the flow of execution during runtime? So quick kind of screenshot off of Lambda FAQ, kind of caught my attention as I was doing the research. Does Lambda support environment variables? Yes, you can easily create and modify environment variables. So initially I started off with, can I store credentials in those? Evidently you can. It's pretty common actually. What are some of the other environment variables that we might be able to manipulate and do unintended things? So further down, I'll talk a little bit more about how we can change the Python path variable and do some interesting stuff with that. What restrictions apply to AWS Lambda function code? So I found this really interesting. Lambda attempts to impose as few restrictions as possible on normal language and operating system activities. So that to me sounds very opportunistic. If it's imposing as little as possible, it's giving you a lot of freedom and flexibility to do almost anything you want within certain parameters anyway. So there are a few activities that are disabled. Inbound network connections are blocked by AWS Lambda. For outbound connections, only TCP/IP sockets are supported, and ptrace debugging system calls are blocked. TCP port 25 is also blocked as an anti-spam measure. Again, kudos to AWS. They've taken a lot of proactive measures to prevent abuse, but we can kind of meander our way through some of these parameters and find some interesting things. How can my application trigger an AWS Lambda function directly? So you can invoke a Lambda function using a custom event through AWS Lambda's invoke API. Only the function's owner or another AWS account that the owner has granted permission can invoke that function. So again, getting back to that disclaimer, these permissions have already been granted. However, there's again a variety of things that you can do within that. And then how do I invoke it over HTTPS? So this will become a little bit more apparent here in a moment, but you can invoke those through a RESTful API using Amazon API Gateway, giving you the endpoint for your function. We can respond to REST calls, get, put, post. So we're going to use AWS API Gateway to be able to retrieve some credentials for the persistent remote access that I mentioned a few minutes ago. So the active reconnaissance. I started off just tinkering around with some code. I think the first attempt I made was like, let's just get an understanding of what the underlying file system looked like, what's on the file system. So if you're hopefully familiar with Python, if you're not, we're just importing a Python package for OS system calls. And I'm just passing the just a local command ls to list the files. So this actually worked originally, and then it stopped. I haven't attempted it again, but I suspect either maybe Lambda caught on to the idea that people might be poking around and didn't want them doing it anymore, or I don't know the reasoning, but it's not worked for me recently. So this is the next thing I did. So basically, right here, what I'm doing is I'm printing out the environment variables. Lambda stores a lot of interesting things in the environment variables. As you can see, hopefully, yeah, it's got a the LD library path. It's got the normal shell path, language, time zone, et cetera, et cetera. What I found really interesting, though, is it's storing AWS session token in the environment variables. So those session tokens are part of the IAM infrastructure that AWS uses to authenticate users and resources. So they're storing it right there, clear text in environment variables. So initially, it seems interesting, maybe innocuous, maybe not a big deal, but as we'll see here momentarily, we can do some really interesting stuff with it. So these four that you see here, AWS Access Key ID, AWS Secret Access Key, basically a username and a password for either a user, or you can use it just for API calls without web console access. So if I wanted to use AWS CLI, or I wanted to write up a Python script using those credentials as part of the Bodo SDK, you can use those credentials to authenticate. Those are static, they don't change unless you go and delete and create new ones. And then we have this AWS security token and AWS session token. So those are, again, the tokens that we saw in the last one. So, and I'm just returning those credentials, and we've got, as you saw in the previous one, now we've got not just the security token, but also the session token. So there's some interesting things about the tokens. They have unless AWS has changed this recently, they have a 60-minute lifetime. So it's going to put some limitation on what we can do with them, but there's a little workaround for that on how we can refresh those and find out the new token and continue our attack. So there, a little of the some of the limitations are, it's kind of a spray and pray approach. We're kind of poking around, seeing what we can find. Iterative API calls are pretty inefficient. It's kind of, not quite brute forcing, but you're really trying to find out in a very inefficient way what can be done. So some of the workarounds, I was thinking to myself, I want to get shell access to this Lambda container, right? I want to go in and type commands and do a little bit more than just writing a Lambda function that pulls back all this data. I want to go in and hands on the keyboard and do it. So reverse shell for the win. So this is some reverse shell code. This is just an example of what I started off with. Basically, we can put a host name or an IP address into this s.connect call and specify a port, and the Lambda function, remember, it can make outbound TCP/IP connections. We can just set up a netcat listener and have this call back to us, and then we can drop into a shell on the Lambda container. So I've got a video of this. I don't know if you prefer a live demo or a video. I can do a live demo, but if it fails, then we can just go to the video maybe. Let me see here. Let me back out of this momentarily. So basically what we're going to do, there's my video. So here's the code right here. I've already got an EC2 instance running. The public IP is 5290.123.83, listening on TCP port 1337. So this is the Linux EC2 instance that I'm going to connect back to. I'm going to set up a netcat listener on that same port. Go back over here, and we're going to test this. Now, one other thing I should notice is we've got a 5-minute limitation on Lambda execution. It's just something AWS imposes. So all the poking around we're about to do, we've got to do in under, 4 minutes and 40 seconds probably now. So we're here in a shell on the Lambda container, and we see that if we do cat lambda function py, you're going to see the function that we saw here. And this is what's being bootstrapped within Lambda, right? So now I'm back at the shell prompt. So first thing that we would want to do maybe is look at etc password. You can see there's a huge number of users in here. Most notably is that these users are one called/user followed by a four-digit number. Presumably SBX stands for sandbox. But all of their login shells are set to sbin no login. So clearly AWS is not expecting us to have a shell on this right now. What I did find interesting is everyone's got sbin no login except for root and where's the other guy? EC2 user. Right? I hope you guys can see that. Actually, let me blow this up a little bit. I didn't realize it was so small. So we've got EC2 user right here with bin bash, and we've got root up here with bin bash. Everything else is sbin no login. So again, AWS is being very diligent on how they lock down their system. So look at the root file system. You can see that there's only going to be one place that we can write. That's in the /temp directory, very common on Linux systems for world writable directory. Let's look at maybe some of the, oh, I got to do this the long way because I don't have it in my path. Config A. So here's some of the interfaces on the Lambda container. One's called, make that a little bit bigger again. Is that better? Yeah. Perfect. So we've got three interfaces. We've got the loopback interface at 127.0.0.1. We've got one called vinternal_3 that's at 169.254.76.5. And we've got another one called vtarget_2 at 169.254.79.1. I wrote a small port scanner in Python to try to go through and see what it might be able to access on ports. Unfortunately, it wasn't able to find much, so AWS is maybe doing something there to prevent any sort of response or any sort of network connectivity through those. I haven't quite figured that part out, but what I suspect these are being used for is AWS has a feature called X-ray. It's kind of like a Lambda debugger. It'll tell you how well it's running and ways to basically improve your Lambda function. So I suspect it's being used for that. So let's just quickly dump the environment variables. This is kind of what we saw earlier on those screenshots. You can see here that we've got this, access key. We've got the secret access key. We've got the security token and the session token. Now, strangely, I noticed the security token and the session token are identical. This seems to keep getting smaller. I'm not sure why that is. Maybe AWS is intending on phasing out one or the other. I just noticed that. So look at the processes. Oops. PS. So we've got basically three processes. We've got our bootstrap PY, and that's a an AWS bootstrap function. We'll take a look at that here in a minute. But that's running, and it's in var runtime AWS Lambda. Oh, no, AWS Lambda. And now we see in there, so they got bootstrap.py is what bootstraps your code, but there's also this init.py. We've also got a shared object file called runtime.so, and that really interested me. Now I want to start tinkering around and see what we can do with the runtime. We'll get to that here toward the end a little bit, but and I just dropped out of my shell. It was perfect timing. So Lambda wrapped up. You can see here that it's going to say, oh, it failed, but it didn't. We had a shell. We were able to go around, poke around, see what was running on the container. So I was able to pull down the bootstrap.py and runtime.so files. So we'll take a look at those in a minute. So thank you, demo gods. That went well. All right, let me get back to the Prezo. Cool. So this was what I just showed you, so we'll just skip past this. So what we've discovered here, and I'll probably just breeze over this one too because it just basically said all this. There's a containerized Amazon Linux. I think what I forgot to do was like a uname A, but it'll tell you that it's It's running an Amazon Linux container. Again, I'm just presuming that it's running on an AWS ECS EC2 cluster. They're going to probably, drink their own champagne, eat their own dog food. They're going to use their own technologies to run this, and ECS just seems the only logical way to do that for AWS. I didn't look at the kernel version because I didn't do the UNAME, but I think it was running 2.6 something. Anyway, we know the compilation date. From that, we can get an idea, if we're going through this periodically, what the release cycle for these Amazon Linux images are for Lambda. So, they have their own release cycle to the public, but I'm going to do a little bit more research and find out if that deviates any for their own internal processes with regards to Lambda. So we saw the network. They're dynamically assigned from what I can tell. So one time it would have been 76.5. It might be 76.2 or 10, then a couple times later. It's on a /23 network. And then the other interface we looked at was a 79.1, and it's on a /32 network. Default gateway is 76.6. So the default gateway is going out the interface of vinternal_3, right, on that /23. So that's likely what is going out to the internet, allowing us to retrieve that reverse shell. And then we saw the EC2 user and root users, an etc password. The nomenclature used was SBX_user and a 4-digit number. So I mentioned X-ray, and this is an area of research I want to continue exploring as well, but it seems like the X-ray daemon always resides at 79.2. And then we know, again, that there's some sort of bootstrapping that's going on for your code, and it's leveraging that runtime.so shared object file. It's making calls to that. So this is some of the stuff I didn't show you. I captured this because I knew if we tried to do all of this in under 5 minutes, it'd be very difficult. But this is just looking at the some of the file system mount points. You can see some of the permissions there. So we've got dev xvda1 all the way through and where that's mounted. We've got read only. We've got read write on /dev. Again, I'm not going to read them all off, but this is just kind of a good overview of the file system and mount points and some of their permissions. Just a quick listing of those directories. Got some symlinks. And so the next thing I started doing, again, remember I said about the session tokens. We're able to take those tokens. If we're able to extract them or exfiltrate them, we're able to take those and then execute code of our choosing of that Lambda function with those credentials. So whatever the Lambda function is able to access, we're also able to access using those credentials. So one of the problems was, again, they only last for an hour as a security feature in AWS, so we need a way to kind of refresh those periodically. So we can grab the access key ID, we can grab the secret access key, we can grab the security and session tokens. What if we were to export those and then just import them into maybe, say, our AWS credentials file? Everyone's familiar with those for AWS CLI? So AWS has a command line interface application for you to interact with their services. And there's a file called credentials, where you can go in and set up different profiles with different credentials. So what we'll do is extract those credentials from the Lambda function, put them in the credential file, and then whatever we attempt to execute with the AWS CLI, we can execute with the Lambda's credentials and the Lambda's permissions. So this is just kind of a quick summary of the events that show up in CloudTrail. And what I'm showing here is that it's an assumed role, and it's using the Lambda access key ID. And you can see that I set up one called my Lambda role. So what I'm pointing out here is that we're now masquerading as the Lambda function or the Lambda container rather than our own credentials. Really good way to kind of hide your activities, if you will. This is just I think this is a CloudWatch, CloudTrail, CloudWatch log. I don't remember. Yeah, CloudWatch. There you go. Thank you. So this is just another logging utility that AWS has. So again, just showing that, when it started, when it ended, who it was executed by, and what it did. Important takeaway is that AWS thinks it's Lambda, not you. So we talked about the lifetime being 300 seconds, and then the security token max lifetime is 3,600 or an hour. So we need to renew those session tokens so we can continue to do whatever it is we want to do. So we want to look at something along the lines of how we gain persistent remote access to this. So some of the ideas, I haven't actually written any code to do this. This is hypothetical, but again, assuming that the Lambda function has the IAM permissions to perform these actions, we could use an HTTP GET to an API gateway and have it invoke the Lambda and execute whatever commands we want. So this is just a real simple scenario. But what we can do is then access those credentials of that Lambda function through a web interface. So your security token expires, you're not getting access. Now we just go in, hit refresh on the browser, and we've got new access tokens, and we can continue doing our research. So again, AWS it can be triggered by a number of sources, but it can also access a number of them as well. So we can perhaps through a browser interface as well access API gateway that calls your malicious Lambda function. And we can start prodding around, doing some reconnaissance on what sort of permissions are in place and what the Lambda function is able to do. So I'm going to move along. I think we're getting short on time here. So I threw this in here because S3 has been kind of all the rage with world readable S3 buckets. All we need to have is get object permissions to be able to pull down contents from S3 buckets. So if we're able to do that, it's not world readable, but the Lambda function can read it. Now we've got a way to exfiltrate data from S3 buckets. Maybe we can do some port scanning. We can have the Lambda function because, again, it can make outbound TCP/IP connections, as we did with our reverse shell. We could start doing, proxied or masqueraded nmap scans, for instance. Start, prodding targets through Lambda, not as ourselves, but as Lambda, to a destination target, and start doing, active reconnaissance on them. So we've got some limitations with this too, right? If it's our own account, it's got some billing costs. If it's someone else's account, like if an attacker is using this or a former rogue employee is using this, that's probably not a concern of theirs. But it does have a higher probability of detection. Everything's going to get logged, and if they start seeing unusual activity, it could trigger something, and a SOC analyst might see or something. So, we still don't have any control over the runtime, execution, and the flow. So we want to then reverse engineer the bootstrap.py and that runtime shared object file that we looked at earlier, so that we can begin looking at how we can control data and execution flow. So these are just some screenshots, and I want to be respectful of Amazon's intellectual property. This is copyrighted material, which is why I'm only going to show you little code snippets that are relevant. But so this is the bootstrap py. You can see that it imports several different Python packages. The important thing here is it's importing runtime from the shared object file as Lambda runtime. So anywhere in the bootstrap py file that you see Lambda runtime function name. It's using something out of that shared object file. Something that I found interesting that happens in the Bootstrap PY's main function before it actually runs your code is it's deleting these OS environment variables. So remember we looked at some of the other ones, they were like the session token, the time zone, and a number of other things. We can't look at those because they're deleted before our code is bootstrapped. So again, trying to get some ideas about how we might be able to actually capture those before our code is executed. But Lambda control socket, shared mem FD file descriptor presumably, control socket, or runtime load time, a number of interestingly named variables that I would really like to get my hands on. So this is really our entry point into the Lambda runtime environment. They make a call to something called wait for start. Wait for start then calls lambda underscore runtime dot receive start. So from what I can tell based off the analysis I've done of receive start, I hope that's big enough, is that it's not big enough for me. That is then calling another, and it does some stuff, but it calls another function called runtime underscore recv underscore start. Well, what does that do? From what I can tell, this is AWS's way of Lambda telling AWS when the Lambda function has been invoked, right? Because they're billing us by the millisecond at a minimum of 1 second up to 300, right? So the idea I start kind of kicking around in my head is there a way maybe that we can tell AWS that, yes, it started, but it stopped, and get billed for 1 second, but continue to execute for the other 299 seconds. That would be really interesting if we could do that. Another interesting thing I would like to explore a little bit more on is with this X-ray. It's taking debugging information, basically, runtime information from your code, and it's displaying it in a web-friendly interface. So is there a way that we can taint that data that's reported, possibly a cross-site scripting payload where we can hijack cookies, maybe an admin or someone with higher privileges than you is viewing that, and maybe perhaps we can hijack their account and access what they have that we cannot currently. So anyway, so we're it's making a call here to get handlers. Again, that calls report user init start. Again, presumably it's doing some sort of time tracking. What I found interesting in this was the comment in the Bootstrap code. It says, this is the old way we were loading modules. Presumably this is someone from AWS that's commenting this in here, but it says it was causing intermittent build failures for unknown reasons. So I just found the comment was still in there, and just found it interesting they left that in there. So this is back, I'm using for this, if you're curious, it's called Hopper. It's like a disassembler debugger for Mac. But just kind of walking through, again, looking at runtime underscore report underscore user underscore init underscore start. AWS likes underscores. So that comes back, and then we've got report done. So thank you. So again, presumably this is telling AWS that the invocations occurred. Stop billing, stop doing any sort of X-ray tracing for debugging. We see here also that again we're billed by the millisecond. So this looks like it is logging the beginning and the end and rounding it to the thousandth, right, for the millisecond building. Again, this is just another example of runtime report done. So again, I want to begin looking at. I talked to a guy at AHA last night, Austin Hackers Association, or is it Anonymous? I forget what it is. AHA. I began talking to him about some ways that we might be able to circumvent some of the controls AWS has in place. They allow you in your Lambda function configuration, you can go in and specify a Python path. So Python path is similar to like Linux shell path. It's looking for a list of directories to look into to load modules. So the idea being, if we can, we can write to /temp. It's the only directory we can write to. If we specify /temp as the Python path and we write our own module, can we then maybe begin to return data that's being called in that runtime and shared object file and somehow taint that data, right? Can we gain control of the execution flow? So what else? So some of the hypothetical possibilities, yeah, spoofing the Lambda runtime. Can we do any sort of malicious code injection, long poisoning? Ultimately, because this is a container, I'd really like to see if we can pop out of the container and hit the ECS cluster, but that's probably a little ways down the road if possible at all. So that's basically all we need to do, is maybe create our own runtime and import it. They'll have it as Lambda runtime, and we can make our own function calls. So how do we mitigate some of this? It's really nothing new, to be honest with you. It's just good housekeeping. Study IAM, get a really good solid understanding of it. DevSecOps has this mantra of you build it, you own it now, which I really like, but getting to know IAM intimately is a pretty difficult learning curve. And they have people that manage IAM only. So for someone to really understand it, plus every other job duty they do, is probably going to be pretty difficult. If you're setting up IAM permissions, AWS gives you that deny by default least privilege model. Just be sure you're not going in and giving any excessive access through roles and policies. Good housekeeping. If someone leaves the company or whatever, make sure their account's provisioned. I've worked at places and I've had clients where they have account provisioning through AD, and it's set up in AWS, and they use single sign-on. But when they've left, access still remains in AWS. It's not revoked. So make sure you got good housekeeping, and then restrict CLI, SDA, and API, or SDK and API access. If they only need API access, don't give people web console access. Just again, least privilege. Test and assess. So this is code. So we're talking about doing application security here. Let's have some peer review on the function code. Make sure this isn't malicious, so that if I know I'm leaving the company next week, I'm not going to put malicious code on there and then be able to invoke it at some time later and still compromise your environment. Integrate that into CI/CD pipelines. Automate it with SaaS pre-deployment preferably, and leverage infrastructure as code as often as possible using CloudFormation templates, Terraform, those types of things, so you can track changes and revert if necessary. Reactive, decoupled account provisioning, check CloudTrail and CloudWatch for IOCs, any sort of suspicious behavior. Maybe you could visualize some of these events with native Elk Stack deployment within AWS. And then leverage the power of the CI/CD automation for your response, and instantly alert a DFIR team upon any sort of detection of malicious or anomalous activity. And then again, revert to known state with CFTs or Terraform. If you detect something fishy, revert back to a known good state. So that's it. Again, if any of you are Python programmers, I'd love to get some input and bounce some ideas off of you. And then again, I'm here for a Q&A now and afterwards. So thanks very much.